Okay, D Angmo. Acha, what's your name exactly? What D stands for?
Dichen Angmos.
What? Pardon?
Dichen Angmo.
Degen.
Yes, sir.
Okay. Anyways, I'll try to memorize this name. Don't worry. But I'm not sure whether I'll be able to do that. But I think gradually with time I'll be able to remember your name. Anyways, so see, we are going to start with the electric field. और बेटा हम ना बिल्कुल basic point से we will start discussing electric field and all these things. Wherever you uh, get some doubt or anything that you don't understand, you please ask without getting hesitated or without being shy. You can ask any of your doubt while studying. ठीक है? For that you
ठीक है,
don't need to take permission. है ना? आपके डाउट आपको खुद ही पूछने हैं. ठीक है?
ठीक है सर.
ऐसा नहीं हो कि मैं पढ़ाता जाऊं. देखो, मुझे देखो कम आता है ज्यादा आता है मुझे नहीं पता, बट मुझे आता है इसीलिए मैं आपको पढ़ा रहा हूं. तो मैं तो
ठीक.
अपने फ्लो में पढ़ाऊंगा, बट आपको कितना समझ में आ रहा है, इट विल आप उसको यू विल बी एबल टू जज इट बेटर. ठीक है? तो इट इज योर ड्यूटी कि इफ यू डोंट अंडरस्टैंड एनीथिंग प्लीज आस्क इमीडिएटली. है ना? स्टॉप मी, आस्क योर क्वेश्चन, आई विल क्लियर योर डाउट एंड देन विल प्रोसीड फर्दर. ठीक है? तो कीप दिस इन योर माइंड. है ना? Okay,
ओके
so
सर.
what is electric field? Let us understand that. So you have already studied the Coulomb's law, means electrostatic force, and you know that whenever the charges are placed without any contact, मतलब these two charges are not in contact. देखो, एक तो ये हो सकता है कि one thing is that कि if the two bodies are in contact, है ना, ये एक body है और ये एक body है, if they are in contact, तो in that case मैं ये कह सकता हूं कि this body, मान लो it is A and this body is B, A will exert force on B and B will exert force on A. So this is called as contact force because this force is acting due to the contact between A and B, right?
यस.
But the force which is called as electrostatic force or the force gravitational force you have studied in class 11, in these kind of forces there is no contact, still there is force. This is called as non-contact force, right? So how does this non-contact force acts? How does this non-contact force acts? Let us understand that. See, what happens whenever you place a charge somewhere? Let's say I have placed a charge here. Okay? So what happens? An, an invisible space is created around this charge in which if another charge is brought in, so that another charge will experience the force of either repulsion or attraction. क्या मतलब हुआ सर इसका? देखो, इसको ऐसे समझो कि आपका एक घर होगा ना,
हाँ सर.
आप आपका घर है, आप उस घर में रहते हो. सिमिलरली मेरा भी एक घर है, मैं उस घर में रहता हूं. तो फॉर एवरी पर्सन हाउस इज अ नेसेसिटी, राइट? और वो उसका रीजन है. मतलब मैं अपने घर में कुछ भी करूं मेरी मर्जी. ठीक है? बात समझ में आ रही है? तो वो हाउस किसी भी, अगर कोई भी इंडिविजुअल है तो उसका घर तो होगा ना. एक आइडियल सिचुएशन की बात कर रहा हूं मैं कि आइडियली हम मान लें कि सब हर इंडिविजुअल का एक घर होता है. उसी तरह से व्हेनेवर यू प्लेस अ चार्ज, उसके अराउंड एक रीजन क्रिएट हो जाता है. ठीक है? एंड दैट रीजन इज सच अ रीजन इन विच अगर मैं कोई दूसरा चार्ज ला के रख दूं, इफ आई प्लेस सम अदर चार्ज इन दैट रीजन, then it will experience a force of attraction or repulsion. For example, बेटे मान लो, in case, although you haven't invited me yet, but मान लो in case if I visit your place, ठीक है, and I come to your house, then I think you will show your hospitality towards me, right?
यस.
कुछ चाय वाय तो पिलवाएंगे ना आप. But
हाँ
if I don't if I don't come to your house, if I don't come to your house, I come to Ladakh but I don't go to your house, तो ऑब्वियसली आप, ऐसा तो नहीं है कि आप मुझे ढूंढ के मुझे चाय पिलाओगे, राइट? तो है ना, चाय पीने के लिए मुझे आपके घर आना पड़ेगा. ठीक है,
हाँ
इसका मतलब आपका घर वो रीजन है in which if some guest comes or you invite some guest, then you will show your hospitality. But if someone is not coming to your house, you are not bound to show any hospitality to that person, right?
right.
Similarly, whenever a charge is placed, a region is created around the charge. If in this region and another charge is kept, this another charge will experience either the force of attraction or the force of repulsion. But if the charge is placed very far from this charge, means outside this region, if some another charge is there but outside this region, so on this charge there will be no force of attraction or repulsion, right? So such a region around a charge in which it interacts mean either it repel or attract another charge, that region is called as electric field. Did you understand?
Yes, sir.
This is that region in which a charge exert a force on another. That is why मैं आपको एक practical चीज बताता हूँ. For example, you take two magnets. Say this is one magnet, this is another magnet. If you'll place these magnets close to each other, मैं ये नहीं कह रहा कि contact में रखो, but इन दोनों का separation, if it is very small, so you will observe either the two magnet will attract each other or they will repel each other, right? But you keep one magnet here, another magnet very far from this magnet. This distance is very, very large. So in that case, you will see that there is no force of attraction or repulsion between these two magnets. Are you getting what I'm saying? कि अगर आपने दो
Yes.
मैग्नेट लिया और दो मैग्नेट को थोड़ा करीब रखा, क्लोज रखा, तो देयर विल बी फोर्स ऑफ अट्रैक्शन और रिपल्शन. क्यों ऐसा होगा? और अगर दो मैग्नेट को आपने बहुत दूर रख दिया तो देयर इज नो फोर्स ऑफ अट्रैक्शन और रिपल्शन. दिस इज योर डेली लाइफ एक्सपीरियंस. ऐसा क्यों? बिकॉज मैं ये कह सकता हूं कि अगर मैंने ये मैग्नेट, फॉर एग्जाम्पल मान लो इसकी जो इलेक्ट्रिक फील्ड का रीजन है वो ये, दिस इज द रीजन ऑफ इलेक्ट्रिक सॉरी मैग्नेटिक फील्ड, मतलब इस मैग्नेट का ये रीजन इतना है कि इस रीजन में मैं दूसरे मैग्नेट को रखूंगा तो फोर्स लगेगा. ठीक है, तो फोर्स लगा. बट अगर मैं दूसरे मैग्नेट को इस रीजन के बाहर रखता हूं तो देयर विल बी नो फोर्स, राइट? तो दिस इज बेसिकली द कॉन्सेप्ट ऑफ इलेक्ट्रिक फील्ड. इलेक्ट्रिक फील्ड इज सिंपली डिफाइंड एज अ रीजन ऑफ स्पेस अराउंड अ चार्ज इन विच इट इंटरैक्ट्स विथ अनदर चार्ज. डिड यू अंडरस्टैंड?
Yes, sir.
अब बेटा मुझे एक बात बताओ कि having said that there will always be a region in which one charge will interact with another charge, does it mean that for every charge this field will have the same strength? I mean, for example, मान लो if I keep a 5 coulomb of charge and I keep 2 coulomb of charge, so undoubtedly around this charge also there will be an electric field and around this charge also there will be an electric field. But tell me one thing, if I place 1 coulomb of charge here in this field and 1 coulomb of charge here in this field at the same distance, क्या फोर्स सेम होगा? इस 1
N-
कूलम पे फोर्स सेम होगा दोनों में?
No, sir.
नो सर, ऑफ कोर्स नॉट, राइट?
Mm.
इसका मतलब बेटा ये जो 5 कूलम का चार्ज है उसकी ये इलेक्ट्रिक फील्ड है और ये उसकी इलेक्ट्रिक फील्ड है, बट स्ट्रेंथ ऑफ बोथ द इलेक्ट्रिक फील्ड इज नॉट सेम. इसका मतलब इलेक्ट्रिक फील्ड इज अ जनरल टर्म. इफ देयर इज अ चार्ज देयर विल बी दिस रीजन कॉल्ड एज इलेक्ट्रिक फील्ड, बट ईच रीजन विल नॉट हैव द सेम स्ट्रेंथ, राइट? इस बात को फिर
Yes.
से मैं ऐसे समझाता हूं कि इफ देयर इज एन इंडिविजुअल, ही विल बी हैविंग सम हाउस इन विच ही इज लिविंग, राइट? बट सबका जो हाउस है, सबका जो घर है, वो एक ही साइज का, एक ही शेप का तो नहीं होगा. आ रही बात समझ में बेटा?
हाँ, sir.
तो वैसे ही अगर कोई भी चार्ज है तो चार्ज के अराउंड फील्ड होगी, बट उस फील्ड की स्ट्रेंथ सेम नहीं होगी.
Mm.
ठीक है, बात समझ में आ रही? इसका मतलब बेटा सिर्फ इलेक्ट्रिक फील्ड कहने से मुझे सिर्फ ये पता चलता है कि देयर इज सम रीजन इन विच दैट चार्ज इज exerting some force on another charge. बट वो कितना स्ट्रॉन्ग फोर्स exert कर रहा है या कितना वीक फोर्स वो लगा रहा है, ये तो मुझे नहीं पता चला. ठीक है, तो to measure that strength of electric field we defined and another quantity which is called as electric field intensity. आ रही बात समझ में? इलेक्ट्रिक फील्ड इंटेंसिटी आप ऐसे समझ लो कि दिस इज सिंपली द पैरामीटर और द क्वांटिटी by which you measure the strength of electric field. मतलब किसी भी इलेक्ट्रिक फील्ड की स्ट्रेंथ कितनी है उसको मेजर करने के लिए हम एक टर्म डिफाइन करते हैं या एक क्वांटिटी डिफाइन करते हैं जिसको हम कहते हैं इलेक्ट्रिक फील्ड इंटेंसिटी. आर यू गेटिंग डियांगमो?
Yes. Yes, sir.
ठीक है. इसका मतलब इलेक्ट्रिक फील्ड इज सिंपली द जनरल टर्म. ठीक है कि एवरी चार्ज विल हैव एन इलेक्ट्रिक फील्ड बट द इलेक्ट्रिक फील्ड ऑफ एवरी चार्ज विल नॉट हैव द सेम स्ट्रेंथ. ठीक है. टू मेजर दिस स्ट्रेंथ व्हाट वी डू वी डिफाइन एन अनदर क्वांटिटी व्हिच इज कॉल्ड एज इलेक्ट्रिक फील्ड इंटेंसिटी. Now, how do we define that? So let us understand. For example, let's say this is a charge whose strength of electric field I want to measure. मतलब ये चार्ज है तो इसके अराउंड इलेक्ट्रिक फील्ड होगी और इस चार्ज के इलेक्ट्रिक फील्ड की स्ट्रेंथ मुझे मेजर करनी है. आई वांट टू मेजर द स्ट्रेंथ ऑफ द इलेक्ट्रिक फील्ड ड्यू टू दिस चार्ज. करेक्ट?
Right.
टेल मी यस और
Yes.
नो.
Yes, sir.
तो वो चार्ज जिसकी इलेक्ट्रिक फील्ड की स्ट्रेंथ मुझे मेजर करनी है उसको हम सोर्स चार्ज कहते हैं. क्या कहते हैं बेटा बोलो?
Source
सोर्स
charge.
चार्ज. है ना? तो
Yeah.
अब कैसे मेजर करेंगे बेटा? मान लो, अच्छा डोंट टेक माय एग्जांपल्स अदरवाइज. ठीक है, डोंट गेट हर्ट बाय दोस एग्जांपल्स. मान लो कि आप कहां से हो?
मैं लेह से sir.
हाँ?
लेह लद्दाख से.
लद्दाख से. ले लद्दाख से. गुड. मान लो इन लद्दाख मेरे दो स्टूडेंट्स हैं. एक आप हैं डी आंगमो
हाँ sir.
और एक है सोनम. मान लेते हैं, है ना? मैं
हाँ sir.
इसके घर भी गया और मैं आपके घर भी आया, ऐसा समझो. ठीक है.
Okay.
मुझे आपने चाय पिलाया और इसके साथ बिस्किट भी दिया, ऐसा समझना. डोंट टेक इट अदरवाइज प्लीज. और सोनम
Okay.
के घर पे मुझे सिर्फ चाय मिली, तो मैं क्या कहूंगा कि किसकी हॉस्पिटैलिटी ज्यादा थी?
मैं
है ना?
आंगों
आपकी
की.
ज्यादा थी. है ना? आपकी ज्यादा थी. आपने चाय के साथ बिस्किट भी खिलाया. ठीक है. तो इसका मतलब है कि अगर मुझे ये चेक करना है कि किसकी हॉस्पिटैलिटी ज्यादा है तो मैं ये चेक करूंगा कि भाई उसने मुझे क्या क्या खिलाया. मान लो जस्ट फॉर एग्जांपल लेट्स से.
हाँ sir.
तो वैसे ही बेटा अगर मुझे इस चार्ज के अराउंड जो फील्ड है उसकी स्ट्रेंथ मेजर करनी है तो कैसे करूंगा? तो हम करते ये हैं कि हम एक दूसरा चार्ज लेके आते हैं. दूसरा चार्ज. ठीक है. और इस चार्ज को जिसको हम लेके आए हैं जिसके ड्यू टू विच आई विल मेजर दिस इलेक्ट्रिक फील्ड इंटेंसिटी, दिस चार्ज इज कॉल्ड एज टेस्ट चार्ज. क्या कह देते हैं इसको? टेस्ट चार्ज.
Test charge.
ठीक है. एक बात याद रखना बेटा, टेस्ट चार्ज की प्रॉपर्टी क्या होती है? ये इसकी प्रॉपर्टी होती है कि इसका मैग्नीट्यूड ऑफ दिस टेस्ट चार्ज वी टेक द मैग्नीट्यूड टू बी वेरी स्मॉल. मैग्नीट्यूड इज टेकन एज यूनिटी. यूनिटी मींस वन. वेरी स्मॉल. एक्चुअल तो टर्म ये है कि टेस्ट चार्ज का मैग्नीट्यूड शुड बी स्मॉल. ठीक है. एक्चुअल टर्म तो ये है. बट उस स्मॉल को हम लोग कितना मान लेते हैं बेटा? यूनिटी, मतलब वन.
One. Yeah.
है ना? और टेस्ट चार्ज की दूसरी प्रॉपर्टी है कि इसका नेचर कैसा रहेगा? तो टेस्ट चार्ज का नेचर विल ऑलवेज बी पॉजिटिव. ठीक है. टेस्ट चार्ज तो आपको मालूम है पॉजिटिव भी हो सकता है नेगेटिव भी हो सकता है, बट टेस्ट चार्ज हमेशा हम कैसा अज्यूम करेंगे? पॉजिटिव. तो इसका मतलब वी विल ओके तो वी विल प्लेस अ यूनिट पॉजिटिव टेस्ट चार्ज एट सम पॉइंट इनसाइड दिस इलेक्ट्रिक फील्ड. ठीक है. इस सोर्स चार्ज की इलेक्ट्रिक फील्ड में एक टेस्ट चार्ज को हम लाके रखेंगे किसी भी पॉइंट पे और इस टेस्ट चार्ज की मैग्नीट्यूड यूनिटी होगी और इसका नेचर कैसा होगा कि इट विल बी पॉजिटिव इन नेचर. राइट? तो अब मुझे एक बात बताओ, है ना बेटा, मुझे एक बात बताओ कि दिस टेस्ट चार्ज विल एक्सपीरियंस सम फोर्स और नॉट? व्हाट डू यू से?
Yes. Yes, sir.
Of course it will experience some force. Of course it will. So the force experienced by test charge divided by the test charge itself is known as electric field intensity. Did you understand? इस चार्ज ने कितना फोर्स एक्सपीरियंस किया? फोर्स डिवाइडेड बाय द चार्ज इज नोन एज इलेक्ट्रिक फील्ड इंटेंसिटी. समझे?
हाँ सर.
नहीं समझे? अगर इसने ज्यादा फोर्स एक्सपीरियंस किया, इफ इट एक्सपीरियंसिंग अ स्ट्रॉन्गर फोर्स, तो मैं कहूंगा इलेक्ट्रिक फील्ड की स्ट्रेंथ ज्यादा है. अगर ये वीक फोर्स एक्सपीरियंस कर रहा है, तो आई विल क्लेम दैट इलेक्ट्रिक फील्ड इन दैट रीजन इज वीक. डिड यू अंडरस्टैंड और नॉट?
Yes
So
sir.
more is the force, I'll simply claim that more is the strength of the field. Less is the force, I'll say that less is the strength of electric field. So this quantity is called as electric field intensity. Clear है ना? अब बेटा मुझे एक बात और बताइए. Force is a scalar quantity or a vector quantity? What type of quantity is a force?
Vector quantity.
Vector quantity. And charge कैसा quantity है? What kind of quantity is a charge?
Scalar quantity.
Scalar quantity. So if you divide a vector quantity by a scalar quantity, the result remains a vector. If you will divide a scalar quantity by vector quantity, sorry, a vector quantity by a scalar quantity, the result will always be a vector. Means electric field intensity is a vector quantity. What kind of quantity it is? Vector quantity. Means electric field intensity will have magnitude, that is some value, as well as it will have some direction. It is a vector quantity. So this is the formula to which is known as electric field intensity. I'm not dictating any definition because you can see that definition from books. Or should I dictate definitions of this? Do you want to write the definition?
No sir, I will.
Okay, you'll be able to write the definition, right?
Yes.
Wherever anything will be required to write, I'll tell you to write, but I don't think this definition you should write because you will find it very easily in the book. So I'm not going in that part. ठीक है? तो electric field intensity is force divided by charge. ठीक है? अब एक और चीज समझते हैं. बेटा मुझे एक बात बताओ कि what will be the value of force between these two? Can I write the value of force as K into Q naught divided by R square?
Yes.
So electric field intensity will be K Q naught upon R square divided by Q naught. This Q naught and this Q naught will cancel out. Means electric field due to a charge at any distance can be written as KQ by R square. This is also the formula to measure the electric field intensity. ठीक है? If you know the value of force, you just divide it by charge, you will get electric field intensity. If you don't know the value of force, do one thing, use this formula, and this will give you the electric field intensity. I hope you have understood this.
Yes sir. Understood.
Okay, write the whatever I have written on the screen, please note it so that we can proceed.
Okay. Okay. Done sir.
Okay, good. Okay, I'm just taking an example, very basic example, just to understand the formula. I'll tell you. My question is, there is a charge of 2 microcoulomb, and I want to measure the electric field intensity at this point, which is at a distance of r is equal to 4 millimeter. Okay, what is the electric field intensity at this point? This is your charge. Which formula will you use here to get the value of electric field intensity at this distance? What will you do?
E equal to KQ upon R square.
Very good. Can you please solve and tell me the result?
Okay.
Okay, try to solve it.
Okay. Sir.
Is it done, beta?
No, sir.
No, sir,
Mac
not yet. Eh?
millimeter. Yes.
Okay, let us solve together.
Okay, sir.
This is the formula that we will have to use here, right? Acha, tell me one thing. What is the value of k? What is the value of k?
9 into 10 raised to power 9.
Okay, good, very good. And what is the unit of this?
Unit
Newton meter
Newton.
square per coulomb square, right? This is SI unit, है ना?
Yes.
Okay, good. What is the value of charge, beta?
Charge.
2 micro coulomb.
Yes.
ठीक है? And what is the distance? That is 4 millimeter. Acha, tell me one thing. Tell me whether I'm correct or not. Just point me that. If I write the value of k as 9 into 10 to the power 9, charge as 2 and distance as 4 square, is it correct or not? Whatever I
No,
have
sir.
written, is it correct? Why it is not right? Why it is wrong?
Because SI unit may.
Yes, very good. So you haven't put everything in SI unit, so you should change this in SI unit. And 1 microcoulomb, I write it here. 1 microcoulomb means 10 to the power minus 6 coulomb. This means that this will become 2 into 10 to the power minus 6 coulomb. And 4 millimeter. 1 millimeter is 10 to the power minus 3 meter. So 4 millimeter will be written as 4 into 10 to the power minus 3 meter. Now I can solve this, right? And we can write electric field intensity as 9 into 10 to the power 9 multiplied by 2 into 10 to the power minus 6 divided by 4 into 10 to the power minus 3 the whole square. Let us solve. Let us solve now. See, 9 and 2 will become 18 into. This is plus power is plus 9 and this is minus 6. So this will become 10 to the power 3. Is it clear, beta?
Yes, sir.
Good. Divided by 4 square is 16 into 10 to the power minus 3 square will be 10 to the power minus 6, not 10 to the power minus 9. This will be 10 to the power minus 6. Why? Because if you have a to the power m to the power n, so what happens? The result is written as a is to the power m into n, right?
Right.
Okay, good. So we can finally write this result as 18 by 16 will become equal to, this will become equal to how much? 9 by 8, 9 by 8 multiplied by, if you'll take this value into numerator, the sign of the power will change. Means if it is negative in the denominator, it will become positive. Means it will become 10 to the power 3 multiplied by 10 to the power 6. So E can be written as 9 by 8 into 10 to the power 9. Did you understand or not? Tell me yes or no.
Yes, sir.
This is the value. And what is the unit of electric field? The unit of electric field is Newton per coulomb. This is the SI unit, right? So just note कर लो इसको जल्दी से. Note it fast.
Yes, sir. Done, sir.
Okay, good. Okay, so let's move on. Okay, so before I take some more examples, before I take some more numericals, I would like to tell you about the direction of electric field. So first we will discuss the direction and then we will take some more examples based on the formula of electric field, right? अच्छा, बेटा मुझे एक बात बताओ, मैंने बोला electric field is a vector quantity. So obviously it will have magnitude as well as direction. I know how to calculate the magnitude. I know that there are two formulas to calculate the magnitude. One is F by Q and another one is KQ by R square. That I know, right? But what is the direction of electric field? To try to understand. If I place a source charge, this is a positive source charge. And if I keep a test charge, तो test charge beta कैसा होगा हमेशा? What would be the nature of a test? Always positive. Very good. This will always be positive. तो बेटा सोर्स चार्ज टेस्ट चार्ज पे कैसा फोर्स लगाएगा? विल इट बी ऑफ अट्रैक्शन और रिपल्शन?
Repulsion.
Okay, so due to this repulsion, this test charge will move towards the source charge or it will try to move away from the source charge?
Away from the source charge.
away from the source charge. So the direction in which the test charge moves, ठीक है, will be considered as the direction of electric field. The direction in which test charge moves is the direction of electric field. Is it clear? For example, if I place this test charge here, right? So this source charge will again repel this test charge. This test charge will go like this. If I place the test charge here, again due to the repulsion, this will try to go away from the test charge. Means at every point, if you place the test charge, those test charge will try to go away from the source charge, right? Means if you have, means what? If you have, try to understand what will be the direction of electric field. First, I'll write that direction of electric field will be, direction of electric field will be the direction in which the direction in which test charge test charge moves or tends to move. Either it moves or it tries to move, right? So means what? Means if you have a positive charge, let's say if you have a positive charge, if you have a positive charge, so due to this positive charge, test charge will always try to move away from this charge. That means electric field due to a positive charge will always be away from the charge. Is it clear?
Yes.
If you have a positive charge, test electric field due to the positive charge will always be away from the charge. Okay. Similarly, if I have a negative source charge, मान लो ये negative charge, and if I place a test charge, in which direction this test charge will try to move? Towards this charge or away from the charge?
Towards the charge.
Oh, of course, towards the charge, because there is force of attraction. This means that if you have a negative charge, if you have a negative charge, electric field due to this negative charge will always be directed towards the charge. ठीक है, तो negative charge की electric field will be directed towards the charge and positive charge की electric field will be directed away from the charge. अच्छा, इसको ऐसे भी बोल सकते हैं हम, बेटा डियांगमो, आप मुझे ये बताओ, electric field are originating from where? What is the initial point of this field? Where from it has started?
Positive charge.
Exactly at positive charge, and it is going away from the positive charge. So I can say that this starts at the charge and will go to infinity. Means for a positive charge, electric field lines, yeah, you can say the direction of electric field is from positive charge to infinity, and similarly for negative charge it is from infinity towards the charge. I hope you have understood this, right?
Yes, sir.
Okay, I'm coming to a next point. Try to understand. The next point is कि मान लो बेटा, if there is already some electric field, let's say if there is some electric field already, if there is an electric field already, and if I keep a positive charge in it, will it experience a force or not?
Yes, sir.
Of course it will. The direction of this force, the direction of this force will be, if this charge is positive, the direction of force will be in the direction of electric field. This will be the direction of force, right? Means on positive charge, force acts in the direction of electric field. Whereas if you take a negative charge, let's say if you take a negative charge and place the same charge in the electric field, again it will experience a force, but the direction of force in this case will be opposite to the direction of the field. Did you understand? Means if there is a positive charge, it will experience the force in the direction of electric field, and if there is a negative charge, it will experience the force in the direction opposite to electric field. Is it clear, beta?
Yes, sir.
Okay, so please draw all this so that हम आगे बात करें. Is it done?
Mm, yes, sir. Done, sir.
Okay. Okay, let us solve a few more numerical problems based on this formula, and then we'll further proceed to the next topic. But before doing that, we will solve few numerical problems based on this formula. E is equal to F by Q, or E is equal to KQ by R square. Okay, my first question is like this. ठीक है, अब समझना क्वेश्चन क्या है. A charge of a charge of 2 microcoulomb is placed in electric field of strength 10 Newton per coulomb, right? If the mass of charge is 20 gram and its initial velocity is 0, find the acceleration of charge. Okay, I am reading this question for you again. A charge of 2 microcoulomb is placed in electric field of a strength 10 Newton per coulomb. If the mass of the charge is 20 gram and its initial velocity is 0, find the acceleration of the charge. Did you understand?
Yes, sir.
Okay. Beta, do you know that F is equal to m into A?
Yes,
Have you
sir.
seen this equation ever? Yes. So from this, can I claim that A is equal to force divided by mass?
Yes, sir.
Means if I know the force, if I know the mass, I can find its acceleration. So try to understand. I'll be using this formula to solve the value of acceleration. I'll be using this. But what will be the value of force? What will be the value of force? Where is the charge kept? कहाँ रखा है हमने चार्ज को?
Electric field.
Where electric field में. तो who will exert force on this charge?
Electric field.
Of course, electric field. And the force, I know that electric field can be written as equal to F upon Q. Means I can write F is equal to Q multiplied by E. The force can be written as charge. What is the value of charge? Is 2 microcoulomb. That is 2 into 10 to the power minus 6. We have converted into coulombs. Multiplied by 10 Newton per coulomb, okay, which is the strength of field. If I solve this, don't you think I'll get 2 into 10 to the power minus 5 Newton as a force?
Yes, sir.
Okay. Now, acceleration is force by mass. That is 2 into 10 to the power minus 5 upon mass. What is the mass of this charge? 20 gram. Is it the SI unit of mass,
Mm,
or should I convert it into SI unit?
no,
I will have to
convert
convert it into
into
SI
SI.
unit. Very good. So 2 into 10 to the power minus 3. So I can write this as 2, and this will become equal to 10. So I can write this as 10 to the power minus 5 upon 10 to the power minus 2. So can I write this as, इसको ऊपर ले जाओ, तो can I write this as 10 to the power minus 3 meter per second square? Did you understand or not? Please tell me.
Yes, sir.
Okay, good. जल्दी नोट करो. Done, beta?
One
Okay, take your time.
done.
Done. Okay, in the same question, if I ask you, try to understand, if I ask you, you have already calculated acceleration, right? If I want to go one step ahead in the same question, so I'm asking you the next part of the question. Okay, I'm not asking you acceleration. I'm asking you find, my next part of the question is find the velocity of charge after 2 seconds, because this electric field will exert force on this charge. Due to this force, this charge will accelerate. If it will accelerate, its velocity will change, right, Diangmo? So if I ask you ki what will be the final
Yes, sir.
velocity of this charge if its initial velocity is zero, how will you solve this? Can you please tell? Can you please give me some idea how to find the velocity?
Final,
Yes, yes, yes.
final, final
I
velocity
didn't.
minus initial
Yes,
time,
yes,
like this.
yes. I mean, you are trying to tell me this equation, right? V is equal to u plus at. Are you trying to say the same?
Yes, sir.
Where u
No.
is initial velocity and v is final velocity. This is final velocity. And you have seen this equation in class 11th as well as class 9th, right?
Yes, sir.
Initial velocity. So I'll just substitute all the values because I have already calculated the acceleration in the previous part of this question. So can I write simply v is equal to u plus at, but u to zero hai. Initial velocity is zero, right? So u is zero plus of acceleration multiplied by time. Am I correct, beta? So v will be equal to, you have already calculated this acceleration and this was 10 to the power minus 3 multiplied by time. Time is 2 seconds, means v की value is 2 into 10 to the power minus 3 meter per second. कोई ज्यादा कोई डाउट, कोई इशू? बहुत ज्यादा डिफिकल्ट है ये?
No, sir.
नो सर,
No, sir.
आसान सा क्वेश्चन है सर, बिल्कुल आसान सा क्वेश्चन है, देयर इज नो डाउट अबाउट इट। नोट कर लो, आगे बढ़ते हैं।
Screenshot ले लिया sir.
कर लिया?
Okay.
अच्छा बेटा, इसी में एक और काम कर देते हैं। ये आपने फाइनल वेलोसिटी भी निकाल लिया, अब मैं आपसे फाइनल वेलोसिटी भी नहीं पूछ रहा हूं, अब मैं आपको एक और चीज कैलकुलेट करवा देता हूं। चलो आप मुझे बताओ, फाइंड, ये मैं हटा देता हूं, फाइंड द वेलोसिटी, है ना? मैं लिख देता हूं फाइंड द डिस्प्लेसमेंट ऑफ चार्ज। डिड यू अंडरस्टैंड? फाइंड द डिस्प्लेसमेंट ऑफ चार्ज आफ्टर 2 seconds। हाउ विल यू सॉल्व? एनी आइडिया? कुछ आ रहा है दिमाग में?
Velocity equal to displacement upon time.
नो
How
नो
you
नो,
are saying?
दिस मोशन इज एक्सेलरेटेड ना डियांगमो?
Yes,
Is
sir.
it accelerated or non-accelerated? Means is there acceleration or acceleration is zero?
Acceleration. Accelerated.
It is accelerated. So you will have to use this equation. I'll remind you the equation. Have you seen this equation ever? S is equal to ut plus half at square. Have you seen this ever?
Yes.
Yes. So
I
this is the equation that, है ना? This you must have seen in this you must have seen in class 11th again. S is displacement. S is displacement. You already know u. A is acceleration. T is time. Tell me what is the value of u here, beta?
zero.
Zero. So can I simply write S is equal to half at square as u equal to zero? Because initial velocity is zero, it is written very clearly. तो कैन आई राइट एस इज इक्वल टू हाफ, ए आपने पहले ही कैलकुलेट कर लिया 10 टू द पावर माइनस 3 इंटू 2 स्क्वायर। तो एस विल बी इक्वल टू हाफ इंटू 10 टू द पावर माइनस 3 मल्टीप्लाइड बाय 4। तो एस विल बी इक्वल टू 2 टू द 4, राइट? So this can be written as 2 into 10 to the power minus 3 meters. Is it clear?
Yes.
नोट कर लो.
Done, sir.
Okay, good. Diangmo will keep it here only. Rest we'll discuss in the next class. Okay. For today, we'll keep this discussion till here. Right?
Okay, sir.
So we'll
Okay,
meet
sir.
again.